morning, good afternoon, guys. I hope you're having a good day so far. We're going to go ahead and do the notes part. You should have set this up in your notebook yesterday. I showed you how to do that in class. And now you guys are going to have to write this in. I typed it out so that you can read it easier, but I do expect you guys to write all this down. Rational exponents, we will define three cases for. Let me get my pen here. Rational exponents. Okay. And there's three different cases. So we're going to look at three different kind of examples of what does it look like when you have an exponent that's a fraction. The first case is, let's say a can represent any number, and you have 1 raised to the 1 over m. Okay. The case 2 is going to be where we have any number, and the exponent is m divided by n. Okay. We're going to look at what these m and n's are going to be, or what they could be in the examples. And then case number 3, so here's the difference. In the case number 1, you have a 1 in the numerator. In case number 2, you could have any number. So it could be like 2, 3, 4, 5, 6, 7, 8. So you'll have any number. And then case number 3 is what happens when you have a negative number in that fraction. Okay, those are the three cases we're going to look at. Please write this down as well. What are rational exponents? We will describe three cases of rational exponents. Write all this down in your notebook. I will summarize the differences between three types of rational exponents. So what I'm going to do is define these three cases and what they mean, and you guys are going to summarize in your notes and in the practice problems. Please write everything that's typed here on the screen and that I wrote, write it down in your notebook. Let's go ahead and go down to some definitions. So a definition is simply this. A rational exponent is just an exponent that is a fraction. That's it. Okay. Oh, it's just fraction. Let's scratch out that S. Write this down, please, as a definition in your notebook. I want you to write a rational exponent is just an exponent that is a fraction. And let's look at the three different cases. So what I'm going to do here is I want you guys to draw like a little grid, like a table. 1, 2, 3. Let's start with that. Okay, draw a little fraction because we're going to put rational exponent. Here we're going to put radical notation. And here we are going to put example. So let's look at case number 1. This could be a raised to the 1 over m. So that's what I'm saying. The exponent, the case here is that the numerator is a 1. Okay, this will always be 1 for this case. And here's what the radical notation looks like. So a raised to the 1 over m is actually the same as saying the root of a and then the 2, oh no, and then the n goes here. I keep drawing an n, m, but it's an n. I'm sorry. That's why I was so lost. This needs to be an n. So change that. That's got to be an n. That's why. So a raised to the 1 divided by n. We rewrite that as the radical. A goes in the inside of the radical, and the n goes up here. Okay, so it's like kind of like the root. And an example of that would be, let's look at 49 raised to the 1/2 power. So what I'm going to say is it's the radical symbol. 49 goes in here, so this number goes inside. And then this goes right here, okay, the n. So that's like saying the square root, it's like saying the square root of 49, and that's going to be 7. I wrote a little bit big, okay? So 49, anything raised to the 1/2 is like the same as saying the square root of. Interesting how kind of that happens. Let's look at case number 2. This is where we're going to have any number raised to m divided by n, where m and n can be any number. And that's going to be, in radical notation, we draw parentheses. N goes here, just like in the first case. A goes here, whatever the number is, and whatever number is in the numerator goes out here outside the parentheses. Okay, so this one's a little bit more complicated, but everything has its place. The A goes inside the radical. The N goes here, and then the M goes out here. Okay, so let's see what that looks like with some numbers. Let's say 16 raised to the 3/4 power. To convert that, first we're going to draw parentheses. Then we're going to draw the radical symbol. The number A is 16, so that goes in the middle, under the radical. The denominator goes here, and then the numerator goes out here. Okay, so the top number goes out here outside the parentheses, the bottom number goes here, and what that says is the 4th root of 16 raised to the 3rd power. So what that means is like the 4th root is what times what times what times what gives me 16. That means I have to have 4 numbers that are the same. When you multiply them together, you get 16. So what times what times what? So we kind of got to work a little bit backwards here and try to figure out what times what is 16. Or in other words, what raised to the 4th power equals 16? Well, I've been doing this a long time and I can get it pretty quick. You guys might have to do a little trial and error. But 2 times 2 times 2 times 2, that gives you 16, because 2 times 2 is 8 times 2 is 16. Times 2 is not, that's 32. Oh, my bad, I'm dumb. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's where it comes from. Okay, so now we got to break it down. 4th root of 16, and we are going to start to use calculators here in about the next week or so. The 4th root of 16 is 2, and then it's all raised to the 3rd power, and 2 times 2 is 4, times 2 is 8. So that's our final answer when we simplify. Okay, let's look at case number 3. This is where you have any number raised to a negative fraction. The radical notation looks like this. We got to write the number 1, the division symbol or the fraction sign, and then you write the same number raised to the same fraction, but now it's positive. It will always follow this format. Now let's take a look at an example. Let's say I have 8 raised to the negative 4/3. So I'm going to write the 1, draw the line, same number, same fraction, but now it's positive. Okay, now remember, we know what 8 raised to a fraction looks like because that's the same as case number 2. So this actually becomes 1. Let me write here. This is like case, let me write in a different number. This is case number 2, where we write parentheses, the radical symbol, and 8 goes inside. The denominator goes here, and the numerator goes out here. So that means what's the third root of 8? So we got to figure out what raised to the third power gives us 8. So that's going to be 1 over 2 to the 4th power. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So then we simplify, and that becomes 1 over 16. Okay. Here's some more examples that I want to work through with you guys, and then I'll give you some practice on the next video. Okay, so what is this? This is case number 1. Now this fraction is only with the m. It does not go with the 2. Okay, it does not belong to the 2. So this is going to be, I write the 2 out here, then the square root symbol, the m goes inside, the 3 goes out here. So it's 2 times the third root of m. Okay, so remember, the denominator goes out here in front of the radical, and this number goes inside the radical. And 2 is just a coefficient, so it stays the same. Okay, let's take a look at number 2. This is going to be like case number 2. And the reason I know it's case number 2 is because I have a number other than 1 as the numerator. So for case 2, that says we keep this the same. We draw the radical symbol, and it goes inside. The 3 goes out here. Draw our parentheses, and then the 2 goes out here. So look, the 2 came out here. The 3 goes here, and the 64 goes inside the radical. Now it's all numbers. When it's variables, like in example 1, we kind of just leave it like that, we're done. But when we have all numbers, that means we can simplify. So we got to find the third root of negative 64. That basically is saying what to the third power will give us negative 64? Well, I know that the third root, or the cube root of 64, is actually 16? No. 2 times 2 is 4. Oh, it's 4. The cube root of 64, I think it's 4. So 4 times 4 is 16. Times 1 more 4 gives me 64. But I want negative. So what if I change these to a negative sign? Negative 4 times negative 4 times negative 4. That'll give me positive 16, and then that'll give me negative 64. Okay, so the answer here is the cube root of negative 64 is actually negative 4. And then I still have this squared out here. So basically I evaluated this part first to get the negative 4, square it, and negative 4 times negative 4 is a positive 16. So we always have to simplify when we have all numbers. Okay. Let's look at example number 3. Obviously, this is an example of case number 3 because we have this negative sign out here. And I know that from the previous example, I'm going to do 1 divided by same base, same exponent, except I change the sign to a positive. And then now this is like case number 1. So I keep the 1, keep the division sign, and I can convert this to x inside the radical with the 4 out here. So this says the 4th root of x. And because it's a variable, I can simply leave it like that. I don't have to simplify anymore. Okay? I know this can be a little confusing, but if you all have any questions, please let me know. I'll give you some examples to work through on Friday and Monday.